When you look up at night, the moon is a quiet, familiar presence. It traces a predictable path, casting a gentle glow. Even though we can't see it happen, that massive sphere of rock acts as an invisible gravitational leash. It gently pulls on our oceans as Earth spins, creating the reliable twice-a-day tides we expect at the beach. But imagine you could snap your fingers and drop a second massive moon directly into Earth's orbit. For a brief moment, it would look like a gorgeous science fiction painting brought to life, two vast spheres glowing side by side. But the physical reality of that second moon would hit the planet almost instantly. Adding a new massive object to our orbit breaks a very precise mechanical balance. It immediately threatens the stability that keeps our Earth safe. The first disaster you would notice is an extreme gravitational tug-of-war over Earth's oceans. Gravity is entirely dependent on mass and distance, and our oceans respond directly to where that mass sits in the sky. This animation shows Earth from above, demonstrating what happens during spring tides. When the two moons align on the same side of the planet, their gravitational pulls add together into one massive, concentrated force, targeting the water below. The oceans respond by surging outward. These amplified tidal waves would crash into continents, completely drowning global coastal infrastructure and erasing coastal cities. Later in the month, during neap tides, the moons drift apart and pull from entirely different directions. The combined forces cancel each other out in some places and stack up in others, turning the ocean surface into a chaotic interference pattern of highly unpredictable waters. Coastal habitation and ocean navigation rely entirely on a predictable rhythm. With two overlapping gravitational fields constantly changing angles, that rhythm is destroyed. This gravitational chaos extends past the shoreline. It actively scrambles the survival instincts of animals across the globe. Entire ecosystems operate on nature's internal clock. Species like sea turtles and nocturnal predators time their migration, reproduction, and hunting exclusively to the consistent light and tidal rhythm of our single moon. Introduce a second light source and a completely broken, conflicting tidal cycle, and those instincts become useless. Predators are exposed by a constantly bright night sky, and marine life is trapped by unpredictable water levels. Species would be forced to rapidly adapt to a hostile, ever-changing biological clock, or they would face mass extinction. To understand why this arrangement cannot possibly last, we have to zoom out into space and look at the planetary scale. This animation shows what physicists call the three-body problem. When you have three massive objects sharing an orbit, they constantly pull on one another. There is no perfect circle here. The competing gravity causes their paths to bend and warp, creating an inherently unstable dance. As these erratic paths drag the oceans and the rocky crust back and forth, the constant chaotic tugging generates immense cumulative tidal friction within the Earth itself. This friction acts like a brake on a wheel. It actively drains rotational energy away from our planet, forcing Earth's rotation to slow down and causing our days to stretch longer at a rapidly accelerated rate. By holding on to a second moon, our planetary system trades its long-term stability for perpetual escalating orbital chaos. Fast forward a few million years. This chaotic dance cannot sustain itself, and the math guarantees it will end in one of two apocalyptic ways. In the first outcome, the chaotic gravitational forces align just right to slingshot the smaller moon outward. It is violently ejected from Earth's orbit and sent tumbling entirely out into deep space. In the second outcome, the complex orbits decay inward. The two moons pull closer and closer until they collide head-on, raining a devastating, fiery field of debris down onto Earth. In the centuries before either end arrives, humanity would look up to bizarre astronomical phenomena. The daytime sky would be dominated by overlapping, partial double eclipses, casting strange, alien shadows across the ground. The striking beauty of a two-moon sky is completely temporary. The strict laws of physics will inevitably force the system to violently correct itself. Which brings us back to the present day and the comforting reality of our solitary moon. It might seem quiet and unchanging up there, but this lone, cratered rock is a stroke of incredible cosmic luck. It acts as a single, perfectly balanced anchor that keeps our oceans predictable and our climate livable. But knowing how the physics work leaves us with an interesting thought. Since multi-moon systems almost always end in violent evictions over billions of years, could Earth have possessed a second moon in its ancient early history, one that was already violently kicked out into the dark? The calm, peaceful night sky we see today might actually be the surviving remnant of an ancient cosmic war.